What happens when a star collapses beyond neutrons? There is an even stranger hypothesis than neutron stars themselves: quark stars, objects so dense that neutrons break down into their most fundamental particles, forming a soup of quarks. In this audiobook, we explore what they are, how they might form, and what signals they could leave us, such as stellar earthquakes called strange quakes, a journey into one of the most extreme and mysterious states of matter in the universe. What significance do these stars have in the vast cosmos? Through them, we can explore the limits of physics and discover how the fundamental forces of the universe operate at their extremes. As we delve into the study of quark stars, we encounter intriguing questions. For example, how do these stars form and how do they differ from others, such as neutron stars? The answers to these questions are not only crucial for understanding the universe, but also invite us to reflect on the very nature of matter. Quarks are the key to this story. These tiny particles are the fundamental building blocks of all the matter we know. There are 6 types of quarks, known as flavors: up, down, strange, charm, bottom, and top. Each of them has unique properties and combines in different ways to form protons and neutrons. Can you imagine a world where these particles are in constant dance, held together by invisible forces? That is the essence of what constitutes matter in the universe. The formation of quark stars is a dramatic process. When a massive star exhausts its nuclear fuel, its core collapses under the force of gravity. This collapse is so intense that it can release an immense amount of energy, creating a supernova explosion. In this chaos, the conditions are perfect for a quark star to form, but what happens after this explosion? How does a quark star stabilize amid such turmoil? The differences between neutron stars and quark stars are subtle but significant. The former are the result of a less extreme collapse where matter remains primarily neutrons. In contrast, quark stars represent a more exotic state of matter. How can we differentiate them in the cosmos? The answer lies in their physical characteristics and how they respond to the forces that dominate them. The equation of state of quark stars is a fascinating concept. This equation helps us understand how matter behaves under extreme conditions. In a sense, it is like a recipe that tells us what ingredients are needed to maintain the stability of these stars. But what ingredients are necessary in such a chaotic universe? Degenerate matter plays a crucial role in this scenario. You would be surprised to know that matter can exist in states so dense that they challenge our usual understanding. What does this mean for quark stars? It means that despite their extreme density, these stars can maintain a certain stability thanks to the properties of degenerate matter. The physics behind quark stars is a constantly evolving field. Quantum mechanics and relativity intertwine in this territory, creating a theoretical framework that allows us to understand these phenomena. But why is this intersection of theories so important? Because it gives us a more complete view of how the universe works at scales we cannot directly observe. Astronomical observations are fundamental to validating our theories about quark stars. Through advanced telescopes and cutting-edge technology, scientists seek signals that indicate their existence. What kind of evidence is needed to confirm that these stars really exist? The answer to this question could change our perspective on matter and energy in the cosmos. The types of radiation emitted by quark stars are crucial for their study. This radiation provides us with clues about their composition and behavior. How can these bursts of energy reveal the secrets of such a distant star? Through careful observation, astronomers can unravel the history of these stars. The role of quark stars in the universe is monumental. They not only affect the evolution of other celestial bodies, but also influence the formation of chemical elements. Can you imagine that quark stars are responsible for creating the building blocks of life itself? Their existence could be the key to understanding how the elements that make up our world are formed. The relationship between quark stars and black holes adds another layer of mystery. When a quark star exhausts its energy, does it become a black hole, or is there a different fate for them? The answers to these questions are essential for understanding the evolution of the universe. In the context of exoplanets, another intriguing question arises. Is it possible that there are worlds orbiting quark stars? If so, what conditions would these planets have? The answer to this question could open new doors in our search for life beyond Earth. The lifespan of quark stars is a topic of debate among scientists. How long can they exist in a constantly changing universe? The factors influencing their longevity are numerous, and each discovery brings us one step closer to understanding their ultimate fate. The search for quark stars is an ongoing effort in the scientific community. Each mission, each experiment brings us a little closer to unraveling the mysteries of the cosmos. What technologies are at play? And how are our capabilities advancing to detect these celestial bodies? Finally, reflecting on the philosophical and existential implications of quark stars takes us to a deep place. What does it mean for us, as human beings, to know about these wonders of the universe? As we explore the cosmos, each discovery invites us to question our place in the vast fabric of space and time. As we conclude this introduction to quark stars, one last question lingers in the air. Are we ready to continue exploring the secrets that the universe has to offer? The answer depends not only on science, but also on our curiosity and desire to understand the unknown. Quarks are one of the most fundamental pieces of the universe's puzzle, but what exactly are they? In simple terms, quarks are subatomic particles that, along with electrons, form the basis of all the matter we know. If we imagine the universe as a gigantic construction, quarks would be like the bricks that allow us to erect the walls and roofs of this cosmic structure. Without quarks, there would be no protons or neutrons, and without them, atoms would not exist, and therefore neither would matter as we know it. Quarks come in 6 different flavors: up, down, charm, strange, top, and bottom. Each of these flavors has unique properties. For example, up and down quarks are the most common, forming protons and neutrons, while the other flavors are more exotic and are found in extreme conditions, such as in the interiors of neutron stars. Can you imagine what a world would be like if only some of these quarks existed? The variety in their combinations is what gives rise to the diversity of matter in our universe. Now, why are they so important? Quarks not only make up matter, but they also interact with each other through a force called the strong force. This is one of the 4 fundamental forces of nature and is responsible for holding quarks together within protons and neutrons. Without this force, quarks simply could not coexist. In a way, the strong force acts like cosmic glue, keeping everything together in the vast fabric of the universe. Quarks are not solitary particles. They always group together in combinations. The most common form of grouping is the triplet, 3 quarks that combine to form a proton or a neutron. But what happens when more quarks combine? In extreme situations, such as inside a quark star, even more complex structures can form, where matter behaves in ways that challenge our understanding. When we talk about quarks, the question often arises, what role do they play in the origin of the universe? The answer goes back to the earliest moments after the Big Bang. In that primordial instant, the universe was a place of unimaginable temperatures and energies, where quarks existed in a free state before joining to form protons and neutrons. So, in a sense, quarks are our cosmic ancestors. They are the original components that gave rise to everything we see today. Imagine quarks as artists on a stage. Each has its own style and skills, but together they create a symphony of matter. However, not all quarks are equal. Some are heavier than others, which influences how they behave in different situations. For example, top quarks are much heavier than up and down quarks, meaning they only exist briefly before decaying into other particles. The interaction of quarks also leads us to think about the future of the universe. How will their properties affect the evolution of stars and galaxies? Learning more about quarks allows us to better understand how stars form and destroy themselves, and how chemical elements are produced from these reactions. Every time we look at the starry sky, we are seeing the result of complex interactions that begin at the quark level. Quarks are so fascinating that they have even inspired theories that go beyond our current understanding. The theory of supersymmetry, for example, suggests that each quark could have an even stranger companion. This idea, although still unproven, opens the door to a world of possibilities in physics. Have you ever wondered how quarks might influence dark matter? There are theories suggesting that they could play a role in the composition of this mysterious form of matter that we cannot see, yet constitutes a large part of the universe. Quarks could be the key to unraveling one of the greatest mysteries of modern cosmology. The beauty of quarks lies in their simplicity and complexity at the same time. They are tiny particles, but their interactions give rise to the immensity of matter that makes up stars, planets, and living beings. Through the understanding of quarks, we are not only learning about physics, but also about ourselves and our place in the universe. In summary, quarks are more than just simple subatomic particles. They are the building blocks of reality. From their role in the formation of matter to their influence on the structure of the universe, quarks are fundamental to understanding how everything around us works. As we continue to explore their nature, each discovery brings us a little closer to understanding the mysteries of the universe. The formation of quark stars is a fascinating phenomenon that occurs in the extreme universe. But how are these unique stars created? The answer lies in the cataclysmic events of supernovae, where the death of a massive star gives rise to the creation of new and mysterious celestial entities. When a massive star exhausts its nuclear fuel, its core collapses under the immense force of gravity, generating conditions that are simply unimaginable. In this collapse, temperatures and pressures reach such extreme levels that electrons and protons combine to form neutrons. However, what happens when the pressure continues to increase? This is where the intriguing idea of quark stars comes into play. In this extreme environment, neutrons can break down into quarks, the subatomic particles that make up protons and neutrons. It's as if matter is shedding its layers, revealing the most basic components of existence. The transition from a neutron star to a quark star is not a simple change, it is a radical metamorphosis. If we imagine a neutron star as a solid block of ice, the quark star would be more like a soup of particles in a completely different state. This state of matter, known as quark matter, behaves in ways that we are still trying to understand. But what does this mean for quark stars? A quark star can be seen as an extreme and dense form of matter. In this state, quarks are not grouped into protons and neutrons, but are free in a sea of particles. This gives rise to unique characteristics that differentiate them from neutron stars. For example, quark stars can be considerably denser and, in turn, more compact. In comparative terms, it's as if you had a lead sphere the size of a marble that weighs the same as a mountain. How do these stars behave in the universe? To understand this, it is essential to know their formation process. After the explosion of a supernova, the remnants of the massive star become what is known as a neutron star. But if the mass of the remnant is large enough, gravity can lead to a transformation into quark matter. This process can be compared to an overflowing river sweeping everything in its path, but instead of water, we are talking about subatomic particles. As the gravitational collapse continues, conditions become increasingly extreme. The pressure is so intense that neutrons are forced to release their quarks, creating a kind of sea of particles. This is a crucial moment in the life of the star. where the transformation from neutrons to quarks gives rise to a new and fascinating entity. But how long does it take for a quark star to actually form? The process is not instantaneous. It can take milliseconds. But the result is a star that can be several times more massive than our Sun, yet with a size that could be even smaller than that of a city. This enormous density creates conditions that challenge our current understanding of physics. How is it possible for so much mass to be compressed into such a small space? That is one of the questions astrophysicists are still trying to answer. An interesting aspect of quark stars is that although they are incredibly dense, they are also extremely unstable. The combination of their high mass and internal structure can lead these stars to collapse into black holes in a relatively short time. It's like having a balloon filled with air that, when punctured, bursts in an instant. But what does this imply for the life cycle of a star in the universe? The existence of quark stars also raises fascinating questions about the evolution of our cosmos. If these stars are the result of the collapse of massive stars, what is their role in the production of chemical elements? These stars could be responsible for creating some of the heaviest elements in the universe, acting as cosmic factories that produce the very building blocks of matter itself. However, there is still much to discover. As we delve deeper into the formation of quark stars, we must also consider the physical theories that govern their existence. Quantum mechanics and relativity play fundamental roles in understanding how these entities behave under extreme conditions. The interactions between quarks and how they combine to form larger particles are a constantly evolving field of study. Finally, the study of quark stars not only enriches our knowledge of the universe, but also leads us to reflect on the very fate of these stars, from their formation to their eventual collapse into black holes. Each stage of their life is filled with mystery and wonder. As scientists continue to explore these phenomena, new questions arise that lead us to a greater understanding of the nature of matter and the cosmos as a whole. Neutron stars and quark stars are two of the most fascinating entities in the universe, but what is the true difference between them? To understand this, it is essential to delve into the mysteries surrounding these incredible stars. Let's begin by exploring their fundamental characteristics. What makes them unique in comparison to each other? Neutron stars, which are the remnants of supernova explosions, form when a massive star exhausts its nuclear fuel and collapses under its own gravity. During this collapse, electrons and protons combine to form neutrons, resulting in an incredibly dense star. Imagine taking a star with the mass of our Sun and compressing it into a space the size of a city. This extreme density is what gives them their name. But what about quark stars? Quark stars are a more recent concept in astrophysics and are believed to be the next step in the evolution of denser stars. Instead of being primarily composed of neutrons, it is thought that in these stars, matter breaks down into quarks, the subatomic particles that make up neutrons and protons. To put it in perspective, if neutrons are like tennis balls stacked on top of each other, quarks would be like the atoms that make up those balls. This transformation occurs under conditions of extremely high pressure and temperature, beyond what we can imagine. How do they differ in their behavior? Neutron stars tend to be stable in their state, remaining as a compact core of neutrons. However, in quark stars, the pressure is so intense that neutrons break down, forming a soup of quarks. This state is known as quark matter. Imagine a mixture of ingredients in a smoothie, where each ingredient is essential and contributes unique properties to the final result. In this case, the mixture of quarks can lead to very different properties. Another key difference between these stars lies in their mass and density. Neutron stars can have a mass up to twice that of the Sun. But when it comes to quark stars, it is speculated that they could be even denser. What would happen if you could stack more and more mass into an increasingly smaller space? Gravity would increase alarmingly, and the forces holding the quarks together could lead to completely different states of matter. This raises intriguing questions about their stability and limits in the universe. Temperature also plays a crucial role in these differences. Neutron stars can reach temperatures of millions of degrees, while quark stars, in theory, could be even hotter. Can you imagine a place where temperatures are so extreme that matter behaves in ways that seem straight out of a science fiction movie? In such an environment, everything we know about matter could change radically. Furthermore, the way these stars interact with their environment is different. Neutron stars are known for emitting radiation in the form of pulses. Thanks to their rapid rotation and powerful magnetic fields, every time they spin, they emit a beam of radiation similar to a lighthouse in the dark. Quark stars, on the other hand, might exhibit less predictable behavior. The way they emit energy and interact with other objects in space is still an active area of research. The lifespan of these stars also presents interesting differences. Neutron stars can exist for billions of years, while quark stars are believed to have a much shorter lifespan due to their unstable nature. What does this mean for the future of the universe? The disappearance of these stars could be related to the evolution of other celestial bodies and their impact on the formation of new stars and planets. One fascinating aspect is how these stars can influence their surroundings. Neutron stars are known for leaving behind energy explosions in the form of supernovae, while quark stars could have even more dramatic effects. What would happen if, upon collapsing, they released such immense energy that it could alter the structure of other celestial bodies around them? The speculation is almost infinite. As we delve deeper into this topic, it is also important to consider how these differences can help us better understand the physics of the universe. Research on quark stars is constantly evolving, and each discovery brings us closer to unraveling their secrets. What revelations does the future hold about these fascinating cosmic entities? The quest for answers about neutron stars and quark stars is not only a journey through the confines of the universe, but also an exploration of the fundamental laws that govern matter. Understanding these differences allows us to appreciate the complexity of the cosmos and our quest to unravel its mysteries. Astrophysics is a constantly changing field, and each new finding can redefine what we know about these stars and their place in the vast universe. In summary, while neutron stars and quark stars share some similarities, the differences in their composition, behavior, and lifespan are profound and fascinating. What other secrets do these stars hold within them? The answer to that question could lead us to new frontiers in the understanding of matter and the universe itself. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The equation of state of quark stars is a fascinating topic that invites exploration into how these stars maintain equilibrium and how their internal structure defines their nature. But what does the expression equation of state really mean? In simple terms, it is a mathematical relationship that describes how matter behaves under different conditions of pressure and temperature. In the case of quark stars, this equation is fundamental to understanding their stability and characteristics. Quarks, those tiny particles that make up protons and neutrons, also play a crucial role in the composition of these stars. Although we cannot see it at first glance, their interaction determines how they group together and behave under extreme conditions. As a star collapses, pressure and temperature rise to unimaginable levels, and this is where the equation of state comes into play, helping to describe how matter transforms. Think of a pressure cooker. When heated, the steam generated inside the pot increases the pressure, preventing the water from evaporating. Similarly, inside a quark star, the extreme pressure created by gravity and thermal energy acts like a lid that keeps the quarks in place. If the pressure is too low, the star could crumble, but if the pressure is just right, the star can remain stable, creating a perfect balance between the gravity trying to crush it and the internal pressure trying to expand it. Now, how is this pressure measured in a quark star? This is where mathematics becomes essential. The equation of state relates pressure, density, and temperature of matter. In the case of quark stars, a simplified form based on the theory of relativity and quantum mechanics is often used. This approach allows scientists to predict how matter will behave as it becomes quarks and how its state will change under extreme conditions. But why is this equation of state important? The answer is simple. It helps us understand the life and death of quark stars. Each of these stars has a limited lifespan. As they age, their internal structure is affected by pressure and temperature, and the equation of state can predict exactly when and how their final collapse will occur. Without this information, it would be like trying to navigate a sea of stars without a map. Scientists have formulated multiple equations of state for quark stars, each with its own characteristics and predictions. Some of these equations suggest that under certain conditions, matter can behave in unexpected ways, such as forming a kind of soup of quarks, where they move freely in a highly energized state. This idea challenges our understanding of matter and raises new questions about how fundamental particles interact with each other. Imagine for a moment that a quark star is in its final phase, just before collapsing. The equation of state plays a crucial role in determining whether the star will become a black hole or disintegrate in a cataclysmic explosion. This decision is not trivial. It depends on the internal pressure and how matter behaves at that critical moment. So every time we observe a star in the sky, we are looking at the result of a delicate balance governed by these equations. In the context of modern astrophysics, the equation of state of quark stars not only provides insight into their structure, but also helps us understand broader phenomena in the universe, such as the formation of chemical elements and the evolution of galaxies. Supernova explosions, for example, create extreme conditions where these equations are vital for understanding how elements are dispersed into space. Without them, the history of the universe would be incomplete. Research on these equations of state is constantly evolving. As astronomers and physicists continue to explore the cosmos, new observations and discoveries may lead to revisions in our current understanding. This means that what we know today about quark stars could change dramatically in the future, offering new perspectives on how they function and how they relate to the rest of the universe. Ultimately, the equation of state of quark stars is not just a set of formulas and numbers, but a window into understanding how matter behaves under the most extreme conditions of the cosmos. Each discovery in this field brings us one step closer to unraveling the mysteries of the universe and our place within it. As we continue to explore and learn, each new piece of the puzzle brings us closer to a deeper understanding of existence itself. The beauty of science lies in its ability to inspire wonder and curiosity. Quark stars, with their fascinating equation of state, remind us that in the vast universe there is always more to discover, and although matter and energy can behave in ways that challenge our intuition, each discovery brings us closer to the secrets that the cosmos keeps so closely guarded. Degenerate matter is a fascinating concept that lies at the heart of modern astrophysics. But what exactly is degenerate matter, and why is it so important in the context of quark stars to understand it? We must first delve into the idea of how matter behaves under extreme conditions. When we talk about degenerate matter, we refer to a state of matter that arises when particles are packed very closely together, to the point where their properties begin to change drastically. Imagine a group of people in a small elevator. At first, everyone can stand comfortably, but as more and more people enter, the space becomes limited, and the situation becomes uncomfortable. In the world of subatomic particles, this scenario intensifies to extreme levels in high-density situations such as those found in the cores of neutron stars. Particles cannot occupy the same space due to a fundamental principle of quantum physics known as the Pauli exclusion principle. This principle states that no two fermions, such as electrons and neutrons, can be in the same quantum state at the same time. Thus, when pressure increases, particles are forced to move to higher energy levels, creating a type of pressure that is essential for the stability of the star. Now, how does this relate to quark stars? Quark stars are even more extreme. In their core, not only are there neutrons, but quarks, which are the fundamental components of neutrons and protons, are released from their usual confinement. This means that the degenerate matter in quark stars behaves in a completely different way than what we know in other stars. It's as if instead of an elevator full of people, we have a crowd that has dissolved into a cloud, where the interaction between particles is entirely different. The degenerate matter in quark stars is characterized by such high density that quarks begin to form a kind of soup of particles. In this state, quarks cluster together to form new combinations, generating even greater pressure than what we see in neutron stars. This pressure is crucial as it counteracts the gravitational force trying to collapse the star. Without this degenerate pressure, the star could not maintain its shape and would disintegrate. But what role does temperature play in all this? As a quark star evolves, its temperature also increases. This thermal elevation causes quarks to move at even greater speeds, which in turn affects the degenerate pressure. Temperature and pressure are intrinsically linked in this context, and any change in one of them can have dramatic effects on the star's equilibrium. Some scientists believe that the degenerate matter in quark stars could be a state that we have never observed in a laboratory on Earth, as the conditions necessary to create and maintain this state are almost unimaginable. However, this does not mean we cannot learn about it through astronomical observation. Every time an astronomer studies a quark star, they are actually exploring a cosmic laboratory where the laws of physics apply in ways we cannot replicate here. As quark stars cool and evolve, they may eventually become even more exotic objects. Some theorists suggest that they could turn into what is known as quark gluon matter, a state of matter believed to have existed in the early universe, shortly after the Big Bang. Isn't it fascinating to think that these stars could be connected to the very origins of the cosmos? Degenerate matter can also influence how chemical elements are formed and destroyed in the universe. During supernova explosions, degenerate matter plays a fundamental role in the creation of heavier elements. This process is essential for the formation of the periodic table as we know it. So in a sense, all of us are made of old stars that have gone through cycles of life and death, releasing degenerate matter in the process. Understanding degenerate matter is not only essential for studying quark stars, but it also opens the door to broader questions about the nature of the universe. What other forms of matter and energy exist that we have yet to discover? How do these fit into the cosmic puzzle that is our reality? With advancements in observational and simulation techniques, scientists are getting closer to unraveling the mysteries of degenerate matter and its role in quark stars. Each new discovery brings us closer to answering fundamental questions about existence, time, and space. Degenerate matter is, in summary, a phenomenon that challenges our understanding and invites us to explore the universe more deeply. It reminds us that while we have made significant progress in our knowledge, there is still much more to discover in the depths of the cosmos. The quest for answers about degenerate matter and its relationship with quark stars is not only a journey through physics, but also a voyage into the very essence of what it means to exist in this vast universe. The physics behind quark stars is a fascinating field that takes us to the limits of our understanding of the universe. But what exactly makes these stars so special? The answer lies in the combination of two of the most important theories in modern physics: quantum mechanics and general relativity. By understanding how they intertwine, we begin to unravel the mysteries of these celestial bodies. Quantum mechanics, in simple terms, deals with the smallest particles in the universe, such as electrons and quarks. Imagine a world where the rules are completely different from those we know. In this world, particles can be in multiple places at the same time and can behave like waves and particles simultaneously. This may seem strange, but it is precisely this behavior that allows quark stars to exist under extreme conditions. Now, how does this relate to relativity? This theory by Einstein tells us that gravity is not just a force that attracts objects, but rather the curvature of space-time caused by mass. When we talk about quark stars, we are discussing objects with such high density that gravity becomes extremely intense. In this context, relativity helps us understand how these stars can exist and how they behave in space. One of the intriguing questions is, what happens when these two theories meet? In the case of quark stars, they form in extreme situations, such as during the collapse of a supernova. Here, the pressure and temperature are so high that matter behaves in ways that our everyday intuitions cannot grasp. The interactions between quarks become essential to understanding how the star is held together. Quarks, which are the fundamental pieces that make up protons and neutrons, group together in combinations to form larger particles. In a quark star, however, the conditions are so extreme that these quarks can separate and behave independently. This raises a fascinating question. What keeps a quark star together? The answer lies in the interaction force between quarks, known as the strong force, which is one of the four fundamental forces of nature. The stability of quark stars is also described by an equation of state, which is a mathematical way of relating different properties of a system, such as temperature, pressure, and volume. But how does this translate into practice? Think about how a balloon behaves when we inflate it. The pressure inside the balloon increases as we add air, and if we keep inflating it, it will eventually burst. Similarly, quark stars must find a balance between gravity, which tries to collapse them, and internal pressure, which tries to expand them. As we delve deeper into the behavior of these stars, we find that degenerate matter plays a crucial role. This concept refers to a state of matter in which particles are so densely packed that their quantum properties begin to dominate. In a quark star, degenerate matter means that the quarks are in a state where the pressure is so high that they behave differently from what we are used to. The physics behind quark stars also involves the idea of degenerate pressure, which acts similarly to a shock absorber in a car. When a car goes over a bump, the shock absorbers help smooth out the impact. In the case of stars, degenerate pressure helps counteract extreme gravity, preventing the star from collapsing completely. As we explore further, we encounter the idea that these stars may influence events occurring in the universe. For example, the collision of quark stars could release a colossal amount of energy, comparable to that of a supernova explosion. This is not only impressive, but also raises questions about how these explosions could contribute to the formation of new elements in the universe. Quantum mechanics and relativity, although often considered separate theories, come together in the context of quark stars to offer a cohesive narrative about the behavior of matter under extreme conditions. Isn't it amazing to think that the very universe we inhabit is governed by these complex interactions? Each quark star is a natural laboratory that helps us better understand how the elements that make up our own environment are formed and evolve. In the end, the physics behind quark stars not only offers us insight into the nature of matter, but also invites us to contemplate our place in the cosmos. If these stars can challenge us to understand the laws of the universe, they also remind us that there is still much more to discover. The quest for answers to these questions drives us into the future and connects us to the very essence of what it means to be human. The yearning to understand our surroundings and our place within them. Did you know that quark stars are one of the most intriguing phenomena in the universe? To understand their existence, we first need to talk about how astronomers can observe them. The reality is that these stars are extremely difficult to detect, but scientists have developed various techniques to do so. One of the most fascinating tools in this search is the X-ray telescope. Imagine a telescope that not only observes visible light but is also capable of capturing radiation that we normally cannot see. X-rays are like a superpower that allows astronomers to look beyond what our eyes can perceive. When a quark star spins, it can emit high-energy X-rays that are captured by these telescopes. But what does this mean in practical terms? It means that, although we cannot see them directly, we can detect their presence through the energy they emit. By observing these emissions, scientists can gain clues about the temperature and density of these stars. Can you imagine being able to measure the temperature of a star millions of light years away? This is possible thanks to the radiation released in the form of X-rays. But it's not just about measuring temperatures. The interactions of quark stars with their surroundings can also be studied. When these stars are in binary systems, for example, they can attract material from their companion, generating even more detectable radiation. Radio astronomy is another crucial technique in this context. Through radio waves, astronomers can capture signals that tell us stories about the universe. How does this relate to quark stars? Often, these stars can emit regular pulses of radiation in the form of radio waves, similar to the beating of a heart. These signals are so precise that scientists can use them as cosmic clocks, helping to measure distances in space and understand the dynamics of these stars. But what about the evidence supporting the existence of quark stars? So far, phenomena have been observed that suggest their presence. For example, some X-ray phenomena that cannot be explained by known neutron stars have led astronomers to speculate about the existence of these more exotic objects. Isn't it amazing to think that by observing the sky, new forms of matter and energy can be discovered? At this point, it's important to mention that quark stars are the result of extreme conditions such as those found in the collapse of a supernova. So, by observing the aftermath of these explosions, scientists can infer the existence of these celestial bodies. This process is a bit like a detective examining a crime scene. There aren't always direct pieces of evidence, but the clues can reveal a broader picture of what really happened. As technology advances, so do the methods of observation. More powerful and sensitive telescopes are in development, which means that in the future we could detect more and more quark stars. Astronomy is a constantly evolving field, and each new technological advancement opens the door to surprising discoveries. Moreover, satellites in orbit and space missions are providing an unprecedented amount of data. Some of these missions are specifically designed to study extreme objects in the universe, including quark stars. Can you imagine what could be revealed in the coming years? The answer to this question could change our understanding of the cosmos. Astronomers have also become more creative in their approaches. For example, they are analyzing the light that passes near these stars to detect changes in their spectrum. This phenomenon, known as gravitational lensing, can provide valuable information about the mass and composition of quark stars. It's like observing how a prism transforms light. By studying these changes, scientists can deduce hidden properties, of course. Each discovery raises new questions. As we advance in our understanding of quark stars, questions arise about their formation, lifespan, and role in the universe. This cycle of discovery and curiosity is what drives science forward. Finally, the importance of international collaboration in this field cannot be underestimated. Astronomers from around the world share their findings and work together on projects that can take years or decades. The search for quark stars is not just a mission for a secluded group of scientists, but a collective effort that transcends borders. Human curiosity is a powerful engine that unites us in the exploration of the cosmos. In summary, although quark stars are difficult to observe, modern techniques and global collaboration are opening new doors. As we continue our search, we not only discover more about these enigmatic stars, but also about the universe as a whole. Curiosity drives us to keep looking up, always in search of the unknown. Who knows what else we will discover in the vast ocean of space? Did you know that quark stars emit radiation that can tell us a lot about their nature? The radiation is like the murmur of the universe, a form of communication that offers us clues about what is really happening in space. But what kind of radiation do these unique stars emit? The answer to this question is not only fascinating but also crucial for understanding their role in the cosmos. Quark stars are like mysterious beacons in a dark ocean. They emit radiation at different wavelengths, which means they are not limited to the visible light we can see with our eyes. In reality, these stars can emit X-rays, gamma radiation, and radio waves, among other types. Each of these forms of radiation provides us with unique information about what happens inside them and how they behave in the universe. X-rays, for example, are like a beam of high-energy light. When a quark star collapses, the pressure and temperature inside become extreme, resulting in an explosion of energy. This energy manifests as X-rays, which can be detected by telescopes specifically designed to capture these wavelengths. Can you imagine what it would be like to capture that otherworldly light which has traveled millions of years to reach us? It's like receiving a message from an ancient navigator of the cosmos. But what about gamma radiation? This type of radiation is even more powerful than X-rays. Supernova explosions, which can give rise to quark stars, are violent phenomena that can release enormous amounts of energy in the form of gamma radiation. This is the most intense form of energy in the universe, and studying it helps us understand cosmic events that would otherwise be impossible to observe. Gamma radiation is like the scream of a star that is about to transform into something completely different. Radio waves, on the other hand, are like whispers from space. Although they are much less energetic than X-rays or gamma radiation, their study is essential for understanding the behavior of quark stars. When scientists detect radio waves coming from these stars, they can gain information about their composition and structure. It's like listening to a distant song that reveals the history of a place. Now the question arises, how do we capture all this radiation emitted by quark stars? The answer lies in the sophisticated tools that astronomers have developed over the years, from optical telescopes to X-ray observatories and radio telescopes. Each of these instruments is designed to detect a specific range of radiation. Imagine a set of tools in a workshop, each intended for a specific task to unravel the secrets of the universe. Each type of radiation provides a piece of the puzzle. For example, when astronomers observe a quark star through different wavelengths, they may notice patterns and variations in the emitted radiation. These patterns can indicate changes in temperature, pressure, and density inside the star. Thus, each observation becomes a chapter in a cosmic story that spans billions of years. The data collected is also crucial for testing existing theories about the physics of these stars. As new sources of radiation are discovered, scientists have the opportunity to adjust their models and theories. For example, understanding how a quark star behaves under extreme conditions can offer clues about the nature of matter in the universe. And that is a topic that fascinates physicists. Moreover, the radiation emitted by quark stars not only has implications for astrophysics, but can also influence other areas of science. For instance, advances in gamma radiation detection have led to innovations in medicine, particularly in cancer treatment, using radiation principles to target malignant cells. Quark stars, therefore, are not only fascinating in themselves, but may also have an impact on our lives here on Earth. By observing quark stars, astronomers are also exploring the possibility that these stars are sources of antimatter. This could open a new chapter in our understanding of the universe and how it formed. What if we discovered that antimatter not only exists in theories but is an integral part of the life of stars? Thus, as we continue to study the radiation emitted by quark stars, we also realize that we are looking towards a future full of possibilities. Each discovery brings us one step closer to unraveling the mysteries of the cosmos and better understanding our own existence within it. Quark stars are not just celestial objects, they are keys that can open doors to new dimensions of knowledge. In conclusion, the radiation emitted by quark stars is a complex yet captivating topic that invites us to reflect on our place in the universe. Each type of radiation, from X-rays to radio waves, offers valuable information about these celestial bodies and their impact on the cosmos. By continuing to explore these stars, we challenge the limits of our knowledge and discover the wonders that the universe has to offer. The quest for answers never ends, and each new question brings us a little closer to the truth. Did you know that quark stars may play a crucial role in the evolution of the universe? These fascinating entities are not only one of the last frontiers in astrophysics, but they are also fundamental to understanding how many of the elements that make up everything we see around us were formed. But how can these stars influence the creation of chemical elements? Quark stars are like cosmic factories, generating extreme conditions that allow for the creation of new elements. At the heart of a star, where pressure and temperature are incredibly high, quarks combine in unique ways. Thus, instead of the elements we know, like hydrogen or helium, more exotic particles can form, leading to the creation of heavier elements. Have you ever wondered where those elements that form stars and planets come from? Quark stars could be behind their origins. As astronomers observe the universe, they have found that quark stars may be responsible for certain cosmic phenomena, such as supernova explosions. When a massive star exhausts its fuel, it can explode in a supernova, and in that process, conditions are generated that allow for the formation of quark stars. Can you imagine what it must be like to see a supernova bursting in space and creating new elements in its wake? As these quark stars evolve, their influence on the universe becomes even more significant. Through their explosions, they can enrich the interstellar medium with essential elements for life, such as carbon and oxygen. Without these stars, the basic components of life as we know it would not exist. How can such a distant star affect life on a small blue planet called Earth? The interaction between quark stars and the cosmic environment is also fascinating. When these stars die, they release enormous amounts of energy and matter, which can be absorbed by other stars and planetary systems. This creates a continuous cycle of creation and destruction in the universe. Isn't it amazing to think that every element that is part of your body may have been created in the heart of a quark star? This life cycle of quark stars also fuels the formation of galaxies. When these stars explode and disperse their elements, they contribute to the dust and gas in space, which eventually clump together to form new stars and planetary systems. Therefore, quark stars not only create elements, but also play a vital role in the architecture of the universe. How can one measure the impact of a single star in the vastness of the cosmos? The existence of quark stars also raises intriguing questions about the balance of the universe. If these stars can produce such heavy elements, What does this mean for dark matter and dark energy, which make up most of the universe? We are still trying to unravel those mysteries. Some theories suggest that they could be related, opening up a range of possibilities about the nature of reality itself. Quark stars also help us understand the extremes of physics. The matter found within them challenges the laws of physics as we know them. This invites scientists to explore more deeply the interactions between subatomic particles and the forces that govern the universe. What other secrets could these stars reveal to us? On the other hand, the study of quark stars offers us insight into the ultimate fate of the universe. As these stars cool and decay, their legacy endures in space through the elements they create. This could influence the next generation of stars and planets, perpetuating a cycle that could last billions of years. Is it possible that we are connected to the universe in a way we have never imagined? As astronomers continue their search for quark stars, each new discovery expands our understanding of the cosmos. Modern technology, such as cutting-edge telescopes and gravitational wave observations, allows us to glimpse the behavior of these stars in real time. What astonishing discoveries await us in the future! Quark stars also challenge us to reflect on our own existence. By learning about their role in the creation of elements and the formation of the universe, we confront profound questions about our place in the cosmos. What does it mean to be part of a universe that is constantly changing and evolving? Studying quark stars is to delve into a territory where science and philosophy intertwine. It reminds us that we are part of a cosmic story that dates back billions of years, where every star, every explosion, and every element has crucial importance. In the end, understanding the role of quark stars is not just an exercise in knowledge, but an exploration of what it means to be human in a vast and enigmatic universe. So, the next time you look at the stars in the night sky, remember that some of those lights may be the result of cosmic processes that began long ago in the heart of quark stars. The connection between these stars and our world is deep and fascinating, and we have only just begun to scratch the surface of what there is to discover. Have you ever wondered what happens when a quark star reaches the end of its life? Often, quark stars are considered mysteries in the vast universe, and their relationship with black holes is a fascinating topic that sparks curiosity. How do these dark holes form, and what role do quark stars play in this process? To understand it, we must first explore the extreme nature of these stars. Quark stars are remnants of supernovae, where matter is compressed to unimaginable levels. In this state, quarks, which are the fundamental building blocks of matter, become so dense that they group together in a quark soup. This extreme density is what sets them apart from neutron stars, which are also very dense but do not reach the quark state. As the life of a quark star progresses, its fate intertwines with that of black holes, a phenomenon that has fascinated astronomers for decades. What happens when a quark star collapses? In some cases, if the mass of the star is large enough, it will not be able to withstand the gravitational force acting upon it. At this point, the star will be pushed toward a catastrophic collapse. Imagine trying to squeeze a soaked sponge. The harder you press, the more compact it becomes. When a critical point is reached, the sponge falls apart and becomes an undefined mass. Thus, a quark star can collapse into a black hole where the gravity is so intense that nothing, not even light, can escape. What does this mean for the universe? Black holes are known to be devourers of everything that approaches them, including stars and interstellar gas. However, the process of black hole formation from quark stars is more subtle than it seems. During the collapse, part of the star's mass is transformed into energy, according to Einstein's famous equation E equals mc squared. This process can release an astonishing amount of energy, leading to brilliant supernova explosions that are sometimes visible from billions of light years away. In the context of the universe, black holes are not just emptiness that devours light. They are believed to influence galaxy formation and the distribution of matter in the cosmos. Some theories suggest that black holes could act as seeds that attract matter around them, helping to form new stars and solar systems. Thus, the cycle of birth and death of quark stars becomes a vital process in the evolution of the universe. An intriguing question that arises is, what happens to the matter that falls into a black hole? The answer is not straightforward. The matter that is absorbed becomes part of the black hole, but in doing so, it is also altered. Information about the original matter is lost, leading to philosophical and scientific debates about the nature of reality and information in the universe. This dilemma has been termed the information paradox, and it is one of the most debated issues in modern physics. On the other hand, not all quark stars have to become black holes. Some may stabilize in an extremely dense state, where quarks remain part of their structure but do not reach the final collapse. This raises a fascinating question. Are there different types of black holes? The answer is yes, and their classification may depend on how they formed, whether from a quark star, a neutron star, or even from the merger of smaller black holes. The connection between quark stars and black holes also has implications for astrophysics. Studying these interactions can help us better understand the nature of gravity and the behavior of matter under extreme conditions. Each discovery about quark stars and their eventual transformation into black holes brings us closer to unraveling the secrets of the universe. Moreover, the study of these stars and their relationship with black holes may open new doors in our understanding of quantum physics and relativity. It has been proposed that at the heart of a black hole, the laws of physics as we know them may not apply. This leads us to question whether there is a unified theory that can explain all these phenomena. Finally, the search for quark stars and their interaction with black holes continues. Astronomers are using advanced telescopes and innovative technologies to detect these cosmic objects in the universe. Each new observation could shed light on the behavior of quark stars and their role in the creation of black holes, as well as in the formation and evolution of the universe itself. The journey through quark stars and their relationship with black holes is a reminder of how vast and enigmatic our universe is. Each discovery brings us one step closer to understanding our place in it and unraveling the mysteries that still await us. Are there exoplanets around quark stars? This question leads us to explore a fascinating and mysterious territory in astrophysics. Quark stars are a type of extremely dense star that forms after the collapse of a supernova. But what does this mean for the existence of planets in their vicinity? The answer is complex and invites us to reflect on the conditions that could allow for the formation of exoplanets in these extreme environments. To understand this, we must first consider how exoplanets form in more familiar stellar systems, such as our own solar system. Generally, planets are created from a disk of gas and dust surrounding a young star. The particles in this disk collide and clump together, forming larger bodies. However, the environment around a quark star is drastically different. The gravity in these stars is so intense that it could destabilize any disk of material attempting to form around it. What about temperature? Quark stars emit enormous amounts of energy and radiation, creating an extremely hot environment. This heat can evaporate any nearby material, making planet formation even more difficult. But could there be a solution? It is possible that at a certain distance, where gravity and radiation decrease, planetary bodies could form. However, this zone would be very unstable and could be pulled apart by the gravitational forces of the quark star. Now let's imagine that there are indeed planets around these stars. What would they be like? Certainly they would not resemble the planets we know. They might be worlds of enormous densities, composed of materials that would not exist in solid form under normal conditions. In such an environment, chemistry itself could take unexpected paths, creating planets with strange properties that challenge our understanding. Life on these planets is also an intriguing topic if we consider that life on Earth is based on certain conditions, such as the presence of liquid water and moderate temperatures. What would happen on a world orbiting a quark star? Life as we know it might be impossible in these extreme environments, but that does not mean that completely different forms of life could not exist, adapted to conditions that seem inhospitable to us. Delving a bit deeper, let's think about the possibility that exoplanets around quark stars could have moons. If planets can form, would they be able to have their own moons? The gravitational dynamics would be extremely complex and dangerous. The moons could be constantly on a tightrope, caught between the pull of their planet and the powerful gravity of the quark star. But what implications would the existence of these exoplanets have for our view of the universe? If we could detect and study planets orbiting quark stars, we would be opening a new window to the diversity of worlds in the cosmos. Each discovery would bring us closer to understanding how planetary systems form and evolve under extreme conditions. The techniques used to detect exoplanets are diverse, ranging from the transit method to radial velocity. However, detecting a planet in such a unique environment as that of a quark star could require technological innovations not yet imagined. As science advances, the possibility of exploring these worlds becomes an exciting challenge. We might wonder, what role do these exoplanets play in the evolution of the universe, perhaps by interacting with their parent star? They could influence the formation of chemical elements and contribute to the complexity of the cosmos. The existence of planets around quark stars may provide clues about the origin of matter in the universe and how the elements that make up everything we know have formed. And of course, we cannot forget the philosophical aspect. If there are planets orbiting quark stars, what does this mean for our understanding of life and the universe? We face the possibility that life has adapted in ways we have never imagined, leading us to reflect on our own existence in a corner of the vast universe. Undoubtedly, the study of exoplanets around quark stars is a field full of intriguing questions and mysteries to solve. As scientists continue to explore these possibilities, we can expect more discoveries that challenge our understanding and expand our boundaries of knowledge. So the next time you look up at the starry sky, remember that there could be surprising worlds orbiting stars that are so different from those we know, waiting to be discovered. How long could a quark star live? This is one of the most fascinating questions scientists ask when studying these enigmatic celestial bodies. To understand this, we must first think about how stars work in general. Imagine a huge ball of hot, bright gas that is constantly undergoing fusion, like the sun. Stars, including quark stars, go through different stages in their life, from birth to death, and each of these stages can last millions or even billions of years. Quark stars, which form after the collapse of massive stars, are an extreme version of this cycle. However, unlike conventional stars, their lifespan is much shorter. This is because inside them, the conditions are so extreme that the nuclear reactions occurring are not the same as those in normal stars. Why does this happen? The answer lies in the nature of quarks and the way they group together to form larger particles. A quark star could begin its life in the cataclysm of a supernova explosion. After this event, the collapsed core can be so dense that matter reorganizes itself, forming a quark star. But here comes the intriguing question: how long can a quark star remain stable before its own gravity destroys it? Scientists estimate that these stars can exist anywhere from a few microseconds to several thousand years, depending on various factors, such as their initial mass and the amount of energy they release. The lifespan of quark stars is also influenced by a fascinating phenomenon known as decay. As these stars emit energy and radiation, they slowly lose mass. It's like inflating a balloon, and as the air escapes, the balloon gets smaller. In the case of quark stars, this loss of mass can lead to a final collapse where the star becomes something even more exotic, like a black hole. This decay process raises another intriguing question. What happens at the end of a quark star's life? While some scientists suggest they could form black holes, others think they might release gamma-ray bursts, extremely energetic cosmic events that could be visible from millions of light-years away. Imagine a star going out in such a spectacular way that it could light up the night sky of distant planets. The lifespan of a quark star may also depend on its environment. If a star is surrounded by other stars or matter, it might experience interactions that alter its evolution. In this sense, it's like a marathon. Runners facing adverse conditions may finish much faster than those with a clear path. The mathematical models that scientists use to predict the lifespan of quark stars are complex. However, in simple terms, they try to understand how the forces of gravity, pressure, and temperature interact inside these stars. Can you imagine a balancing act between opposing forces? That's how scientists visualize this process. Predictions about the lifespan of quark stars are, of course, just that, predictions. As technology advances and we gather more data, our models may change. New observations could reveal more about the nature of these stars, and perhaps their lifespan will extend beyond what we ever thought. In summary, the life cycle of a quark star is a fascinating and complex journey. From its formation in the chaos of a supernova to its possible transformation into a black hole, each stage of the process is filled with mysteries. The duration of its life, on the other hand, is a reminder of how fleeting existence can be even in the vast universe. So, the next time you look up at the starry sky, remember that each star has its own story, and some of them, like quark stars, are truly extraordinary. This quest for knowledge invites us to keep exploring, questioning, and marveling at the immensity of the cosmos and what still remains to be discovered. The search for quark stars is one of the most fascinating adventures in the field of modern astrophysics. Why are these stars so elusive? What challenges do scientists face in their quest? As we delve into this topic, we will uncover the efforts and innovations that are shaping our understanding of the universe. For decades, astronomers have been on a constant quest for new celestial bodies. Quark stars are a theoretical phenomenon that has captured the imagination of many, but detecting them is a titanic task. How can one observe something that, at its essence, is beyond our conventional understanding of matter? The answer to this enigma lies in the combination of advanced technology and astrophysical theory. The first step in this search focuses on understanding how these stars form. After a supernova explosion, what remains can be a neutron star or, under extreme circumstances, a quark star. But how do we know that the latter actually exists? This is where theory comes into play. Mathematical models and computer simulations provide us with clues about the necessary conditions for the formation of these stars. One of the most promising methods for detecting quark stars is through the observation of gravitational waves. When two extremely dense bodies, such as quark stars, collide, they generate ripples in the fabric of space-time that we can capture with special instruments. These events are like the echo of distant thunder, indicating that something extraordinary has happened in the universe, even if we cannot directly see what occurred. The use of gamma-ray telescopes is also crucial. These stars emit radiation at wavelengths that are difficult to detect, but can reveal vital information about their existence. It's like trying to hear a melody at a noisy concert. You need the right instruments and a precise focus to distinguish that beautiful symphony. Additionally, astronomers are employing spectroscopy techniques to investigate the characteristics of celestial objects that could be quark stars. By analyzing the light they emit, they can infer their composition and structure. Each star has its own fingerprint in the light spectrum, and with a bit of luck, this information may provide clues about its nature. International collaboration is another key element in this search. Astronomers from around the world share data and resources, joining forces to unravel the mysteries of the cosmos. This collective effort is similar to a team of detectives working together to solve a complicated case. Every small finding can be the crucial piece that completes the puzzle. An intriguing question that arises is, could there be more quark stars than we have been able to identify so far? The answer is a resounding yes. The universe is vast and full of surprises. As we improve our technologies and observation methods, we are likely to discover new types of stars that were previously invisible to us. In this context, the development of next-generation space telescopes becomes essential. With the ability to observe from outside the Earth's atmosphere, these instruments can capture radiation that would otherwise be lost. Are we on the brink of a monumental discovery? It's an exciting possibility that keeps scientists on edge. The search for quark stars also raises philosophical questions. If we manage to detect them, what would that mean for our understanding of the universe and ourselves? Each discovery brings us closer to answering fundamental questions about matter, energy, and life itself. Meanwhile, experiments in terrestrial laboratories continue. Scientists are attempting to recreate the conditions that could generate quarks using particle accelerators. This approach could provide clues about how these stars function in a controlled environment. It's like trying to recreate a storm in a bottle, complicated but not impossible. Computer simulations are another valuable tool. Researchers create models that simulate the behavior of quark stars under various conditions. How would they react to different forces? These simulations help us formulate hypotheses that can then be tested in the real universe. One of the most fascinating questions is, what would happen if we found a quark star? The impact on astrophysics would be monumental. It would force us to revisit existing theories and consider new possibilities about the nature of matter and fundamental forces. Finally, the future of the search for quark stars is bright and full of promise. As we advance in our understanding of the cosmos, we are increasingly close to unraveling these mysteries, and so the search continues, driven by human curiosity and the desire to understand our place in the vast universe. With each new discovery, we move a little closer to the truth about these enigmatic stars and their role in the grand scheme of existence. Quark stars are a fascinating enigma in the vast universe we inhabit. As we explore their influence on cosmology, intriguing questions arise. How could these stars change our understanding of the cosmos? What role do they play in the history and evolution of the universe? In this section, we will unravel the impact of quark stars on the fabric of the universe and their relationship with cosmic phenomena. Quark stars are the result of extreme gravitational collapses that can occur at the end of a massive star's life. But why are they so important for cosmology? One way to understand their relevance is to think about how more common stars, like our Sun, manufacture elements through nuclear processes. At the end of their lives, these massive stars may end their existence transforming into neutron stars, or, in even more extreme cases, into quark stars. This latter type may serve as a natural laboratory where conditions are created that are not found anywhere else in the universe. By studying these stars, astronomers can gain clues about the matter and forces that govern the universe. For example, quark stars are believed to help solve the mystery of dark matter. Can you imagine if these stars were part of the solution to one of the greatest enigmas of modern physics? Dark matter constitutes about 27% of the universe, but its nature remains a significant question. The properties of quark stars, such as their density and the behavior of matter within them, could offer valuable connections that help us better understand this phenomenon. Quark stars also have a direct connection to black holes. When a massive star collapses, it can become a quark star, but under even more extreme conditions, it can continue collapsing into a black hole. This transformation process raises profound questions. What happens to matter inside a black hole? Could the matter from quark stars be involved in that mystery? The relationship between these two cosmic entities suggests that by investigating quark stars, we might also discover more about black holes and their behavior. Another way to view the importance of quark stars is through their influence on the formation of chemical elements. When supernova explosions occur, they release a vast amount of energy and matter into space. This matter can interact and fuse, forming new elements that are the building blocks of everything we see around us. Quark stars may be part of this creation cycle, contributing elements to the gas and dust clouds that will become new stars and planets. We cannot overlook the possibility that these stars could serve as laboratories to study physics under extreme conditions. Within them, the forces at play are so intense that current physics models could be challenged. This leads to a fascinating question. What discoveries could we make if we could study quark stars directly? The search for these stars takes us to explore the nature of matter at a fundamental level, which could have implications in particle physics and beyond. Research on quark stars also invites us to reflect on the fate of the universe. Through their study, scientists are trying to understand how these stars might influence the expansion of the universe and its eventual fate. Are we facing the possibility that quark stars are part of the answer to whether the universe will expand forever or eventually collapse? Moreover, the study of quark stars may provide clues about the early history of the universe. By understanding how they formed and evolved, we can gain insights into the conditions that prevailed in the primitive universe. This leads us to a natural curiosity. What was the universe like just after the Big Bang? What events led to the formation of the first stars and galaxies? Quark stars also lead us to question our own existence. If these stars are capable of creating new elements and affecting the evolution of the cosmos, what does that mean for us, human beings who inhabit only a small corner of the universe? Are we ultimately made of quark stars? This connects us to the idea that everything in the universe is interconnected, and that every element that makes up our bodies has a cosmic history. There is no doubt that the search for quark stars has opened new avenues of research in cosmology. Scientists are using advanced telescopes and innovative technologies to detect these stars and study their properties. But the path is not easy. As we advance in this search, we face challenges that require ingenuity and creativity. In conclusion, the influence of quark stars on cosmology is profound and multifaceted, from their connections with dark matter and black holes to their role in the creation of elements and the history of the universe. These stars are an essential component for understanding the cosmos. By continuing to explore their nature, we are not only unraveling the secrets of the universe, but also reflecting on our own existence and place within it. The quest for answers about quark stars leads us to better understand the vast and mysterious universe we live in, inviting us to keep exploring and learning. Have you ever heard the term quark star? If your answer is no, don't worry. In the fascinating world of astrophysics, there are many myths surrounding these mysterious stars. The curious thing is that, although they are the subject of scientific study, stories have been woven that are far from reality. The first question that arises is, what is a quark star really? To begin with, it is essential to understand that they are not as common as the stars we see in the sky. While neutron stars are more well known and have been directly observed, quark stars are a more recent hypothesis. It is thought that these stars could form under extreme conditions, far beyond what matter can withstand. However, the idea that they are simply denser stars is a myth. In fact, their composition is radically different. The concept that quark stars are just a more powerful version of neutron stars is incorrect. Although both are extremely dense, in the case of quark stars, the quarks that make up protons and neutrons are unleashed, creating a completely new state of matter. But why should we care about this? The answer lies in the role these stars could play in our understanding of the universe. Another popular myth is that quark stars can explode with colossal force, as if they were cosmic time bombs. While it is true that they can release enormous amounts of energy, that is not their only intriguing characteristic. These stars are, to a large extent, a puzzle that scientists are trying to solve. Their existence could help us understand phenomena like dark matter and dark energy, two of the greatest mysteries of modern cosmology. It is often mentioned that quark stars could be a form of dark matter. However, this is a topic of debate among scientists. While some believe that these stars could contribute to dark matter, others suggest that they are completely different entities. The confusion arises from the way matter and energy are conceptualized in the universe. All of this may sound complex, but essentially it is about understanding what composes the cosmos around us. Another misconception is that quark stars are a recent phenomenon, something that has only been discussed in the last few decades. However, the theory behind them has existed for a longer time. The notion that matter can exist in states beyond what we know has been a point of interest in physics for years. The search for these stars reflects our human desire to understand our surroundings. Quark stars are often thought to be unreachable, like a distant dream. But the reality is that the scientific community is actively searching for them. New techniques are being developed to study these stars, and although we have not found one yet, more data is generated every day that could lead us to discover them. This effort is not just an academic exercise. It could change our understanding of fundamental physics. One of the most persistent myths is that quark stars are extremely dangerous. While it is true that they are incredibly dense entities, they do not pose a direct threat to us. They are so far away in the vast universe that even if they existed, their influence on our planet would be minimal. It is important to demystify this idea, as it often leads us to think that there are cosmic forces beyond our control. The fascination with quark stars also raises questions about the future of the universe. Could these stars be the next step in stellar evolution? This idea has led to speculation about how the universe might change over billions of years. But while these questions are intriguing, we must remember that we are at the frontier of knowledge. Each answer generates new questions, and that is what makes science so exciting. Some wonder if quark stars could harbor forms of life. Although this idea may seem a bit far-fetched, it is a good example of how myths intertwine with science. Life, as we know it, requires specific conditions, and quark stars are likely not the right place for that to occur. However, thinking about it helps us expand the boundaries of our imagination. The idea that quark stars are related to black holes has also captured the attention of many. While both are extremes in the universe, their relationship is not so simple. Some scientists believe that quark stars could become black holes, but that process is still being investigated. The interconnection between these cosmic phenomena is an area where mystery persists, and it is one of the points that intrigues astronomers the most. In the end, the search for quark stars is a journey of discovery. Science is advancing rapidly, and new findings are being made every day that could rewrite what we know about the universe. As we continue our exploration, it is essential to keep an open mind and question what we think we know. Curiosity is the engine of science, and it is what drives us to unravel the secrets of the cosmos. Finally, it is vital to remember that while myths can be entertaining, they should never replace knowledge based on evidence. Science is not about absolute certainties, but rather a continuous process of learning. So the next time you hear about quark stars, remember that there is much more than meets the eye. Curiosity and an open mind are the most powerful tools we have to understand the universe, so keep asking, keep exploring, and never stop being amazed by the wonder of the cosmos. Have you ever thought about how the knowledge of quark stars could change our understanding of the universe? Research in this field is as exciting as it is challenging, as scientists delve deeper into the study of these enigmatic stars. New questions arise that lead us to explore uncharted territories. One of the most intriguing aspects is the search for new ways to detect these stars. Imagine a hidden treasure in the vast ocean of space, where each wave represents a new discovery. Astronomers equipped with their telescopes and advanced technology are getting closer every day to unearthing that treasure, but what methods do they use to do so? From X-ray telescopes to gravitational waves, the variety of tools at their disposal is impressive. Gravitational waves, for example, are like the ripples generated in a pool when you throw a stone. When two extremely dense objects, such as quark stars, collide, they generate waves that travel through space and that we can detect here on Earth. This type of research not only seeks to confirm the existence of these stars, but also to better understand how they interact with the universe around them. But what about computer simulations? This is another fascinating approach. Just as a film director uses special effects to create imaginary worlds, scientists create simulations that model the behavior of quark stars. These simulations allow us to predict how they might behave in different situations, helping us visualize phenomena that would otherwise be invisible. One question that emerges from these simulations is, can quark stars be the source of even more extreme phenomena such as black holes? The connection between these two entities is an area of research that promises to reveal secrets about the death of stars and the ultimate fate of matter. Understanding this relationship could open new doors in theoretical physics. However, the challenges are enormous. The search for quark stars is like trying to find a needle in a cosmic haystack. Their extremely dense nature and particular radiation make them difficult to observe. This is where international collaboration comes into play, as teams of scientists from around the world combine their efforts and innovations to tackle this enigma. Interdisciplinarity is key on this journey. Physics, astronomy, and engineering intertwine to create a rich and dynamic research landscape. Each discovery in one field can resonate in another, like an echo traveling through the mountains of human knowledge. Therefore, we are not just talking about quark stars, but about a collective effort that unites the scientific community. Moreover, the formation of new theories is a fascinating aspect. How do ideas about quark stars develop? Often, they arise from the observation of strange phenomena in the cosmos. A star that emits radiation in an unusual way may be the spark that ignites a new hypothesis. This is the essence of science. A continuous cycle of observation, hypothesis, and experimentation. Meanwhile, human curiosity continues to drive research. The question of whether there are exoplanets orbiting these stars is one of the most exciting. Imagining distant worlds in extreme conditions where life could adapt in unexpected ways is a topic that fascinates both scientists and dreamers alike. On the other hand, the philosophical implications of studying quark stars are profound. Each new finding leads us to reflect on our place in the universe. Are we alone in this vastness? What does the existence of these stars mean for the history of the cosmos and for our own existence? Science is not just a set of data. It is a quest to understand who we are in the grand scheme of things. Looking to the future, research on quark stars is constantly evolving. New technologies are emerging, and with them, new opportunities for exploration. As our telescopes become more powerful and simulations more sophisticated, the possibilities are endless. It is crucial to stay informed about these advancements. Every discovery in the field of astrophysics can have unexpected repercussions in other disciplines. What we learn about quark stars today could illuminate areas of science that we have not even begun to explore. The next time you look up at the starry sky, think about all that is yet to be discovered. Quark stars are just a small part of a vast puzzle, and each piece we fit together brings us closer to understanding the history of the universe. The search continues, and every step we take brings us closer to unveiling the secrets of the cosmos. Human curiosity, fueled by science, is the light that guides us on this endless adventure. Have you ever wondered what mystery lies behind dark matter, that enigmatic substance that makes up almost 95% of the universe? It's as if we are in a vast ocean surrounded by water, but unable to see the liquid that supports us. In this context, quark stars emerge as a possible key to unraveling this cosmic enigma. Could these fascinating stars have a connection to dark matter? To understand this connection, it's important to remember that dark matter does not interact with light in the same way ordinary matter does. It doesn't shine, doesn't reflect light, and behaves in ways that seem strange to us. However, its presence is felt in the way galaxies rotate and move. This is where quark stars come in. These stars, composed of quarks tightly packed in an extremely dense state, could be a form of matter that we have yet to fully recognize. Quark stars are like a more extreme version of neutron stars, which are already incredibly dense. Imagine you have a soccer ball and compress it until its size is smaller than a pea. That is the density you might find in a quark star. Now, think about how this density could influence the way dark matter interacts. Could it be that some of these quark stars play a role in the composition of that dark matter? One of the theories that has emerged is that quark stars could be a component of dark matter. This is due to their dense nature and the unusual properties they exhibit. Some scientists suggest that just as neutron stars originate from gravitational collapses, quark stars could have emerged in the early moments of the universe. So what if these stars are like pieces of a puzzle that help us complete the picture of dark matter? It's interesting to think that these quark stars, being so compact and having such unique properties, could interact with dark matter in ways we do not yet understand. Imagine that dark matter is like a fog enveloping the universe, and quark stars are like beacons emitting special lights in that fog. What if by studying these stars we could uncover new types of interactions that bring us closer to understanding dark matter? Scientists are actively exploring this connection. Through astronomical observations and simulations, they are trying to unravel how quark stars could influence the formation and distribution of dark matter in the universe. This leads us to the question, could quark stars be responsible for some of the anomalies we observe in the rotation of galaxies? The data suggests that there is something beyond what we can see, and these stars could be an important clue. Furthermore, the way quark stars emit radiation could be crucial in this context. The radiation they produce might interact unusually with dark matter, revealing more about its nature. Imagine that every time a quark star emits light, it is sending a message across the universe. What secrets could that light unveil about dark matter? Some theoretical models suggest that if quark stars are indeed part of dark matter, they could be involved in the formation of larger structures in the cosmos, such as galaxy clusters. In other words, they could act as the fundamental building blocks that, although invisible, are responsible for the architecture of our universe. This raises a fascinating question. Could the search for quark stars help us understand how the universe organized itself in its earliest stages? However, not everything is straightforward. The connection between quark stars and dark matter is still an evolving field of research. As scientists continue to explore these stars and their properties, they must also consider other aspects. For example, what other forms of matter could be involved in the story of dark matter? How do quark stars fit into that larger puzzle? As we move forward in this exploration, the future promises to be exciting. Space missions and next-generation telescopes are enhancing our ability to observe the universe. As we gather more data, we may begin to see clearer connections between quark stars and dark matter. It is a journey that will take us to the limits of our knowledge and perhaps to new revelations about the nature of the cosmos. Finally, it is important to remember that the search for answers about dark matter and quark stars is not just a scientific matter. It is also a reflection on our place in the universe. These questions remind us that while we know a lot, there is still vast unexplored territory. The connection between these stars and dark matter could be another step on the ladder toward a deeper understanding of the universe. Thus, the search for quark stars and their relationship with dark matter is not only a challenge for science, but also an invitation to continue exploring, investigating, and marveling at the mysteries of the cosmos. On this path, each discovery can be a spark that ignites new questions and new scientific adventures. The universe is full of surprises, and we are here to uncover them. The search for understanding the universe has been a constant throughout human history. We have wondered since time immemorial what our place is in the vast cosmos that surrounds us. Quark stars, those mysterious and fascinating entities, offer us a unique window into these existential reflections. But what do they really tell us about our existence and the universe? Let's consider for a moment the nature of matter, everything we see around us. From the rocks we walk on to the stars that light up the sky is made up of atoms. But have you ever thought about what lies beyond atoms? This is where quarks come into play, those tiny fundamental building blocks that make up matter. The existence of quark stars invites us to reflect on the very structure of the universe and the forces that govern it. If these quarks can group together to form something as impressive as a quark star, what are the limits of matter? Let's say these stars are like a cosmic puzzle. Each piece, each quark, contributes to a larger and more complex picture. But what happens when we start to take that puzzle apart? What do we discover about ourselves and the cosmos? By studying quark stars, we face profound questions about the nature of reality and the interconnectedness of everything around us. The idea that these stars might be related to dark matter is an intriguing topic. Dark matter, which makes up about 25% of the universe, remains an enigma. If quark stars can be a part of this puzzle, does this mean there is more than we can see and understand? Perhaps dark matter is not just a void, but a form of matter that we have yet to fully grasp. Moreover, there is a fascinating philosophical aspect to this exploration. The existence of quark stars challenges our perception of what we consider normal in the universe. If such strange and dense objects can exist, what other forms of life and matter might be hidden in the darkest corners of the cosmos? The possibility that other types of stars or even civilizations exist under conditions we cannot imagine opens a new horizon of speculation. Time is another concept affected by these stars. Quark stars are believed to have a very short lifespan compared to other stars. But what does this mean for our understanding of time in the universe? If time is an endless cycle, how do these fleeting entities fit into the grand scheme of creation and destruction? This leads us to question the nature of time itself and how our lives are just a moment in the vast symphony of the cosmos. The search for quark stars can also be seen as a metaphor for our own quest for meaning. In our daily lives, we often seek answers to questions that seem unreachable. However, scientists, in their attempts to find these stars, are searching not only in the sky, but at the very core of existence itself. As they strive to unravel the secrets of the universe, we too can reflect on our own personal quests. Exploring the universe through quark stars can indeed help us rethink our relationship with nature. It reminds us that we are part of something much larger than ourselves. Each quark in a quark star can symbolize the small moments of our lives that, although they seem insignificant on their own, combine to form something extraordinary when viewed together. Quark stars could be considered a cosmic mirror. They invite us to look at ourselves and question our beliefs and perceptions. Asking ourselves what we really know about the universe can open doors to new knowledge and realities. Each discovery about these stars not only expands our understanding of the cosmos, but also of ourselves. So as we contemplate the immensity of the universe and the possibility of quark stars, we are reminded that knowledge is a journey. A journey that does not have a clear final destination, but guides us through a maze of questions and discoveries. Science and philosophy, although often presented as two distinct paths, can actually intertwine in this search for answers. It is evident that quark stars, although they are extremely distant and different entities, have an intrinsic power to inspire us. They show us that the universe is full of surprises and that each new discovery can change our way of understanding life. But are we really prepared to accept the unknown and the strange? Every time we look at the starry sky, let us remember that those stars, whether they are quark stars or of another kind, are witnesses to our existence. They watch us as we try to decipher the mysteries of life and the cosmos. Perhaps in every flicker of light there is a story to tell, a lesson to learn about our own humanity. The connection between quark stars and our lives may be deeper than we imagine. And as we continue to explore, the horizons of our understanding will expand. Thus, at the end of this reflective journey, we are left with a question. How does our search for knowledge influence our own existence and our place within the vast universe? Perhaps like quark stars, our essence is a unique blend of experiences, questions, and discoveries that define us as human beings. The vastness of the universe is filled with mysteries, and among them, quark stars shine with a peculiar glow. But what do we really know about them and their role in the cosmos throughout this journey? Throughout this, we have explored their formation, characteristics, and how they relate to other astronomical phenomena. However, at the end of the day, what truly matters is how all of this connects with our understanding of the universe and our place within it. The existence of quark stars leads us to a fundamental question. What does it mean for us to discover that there are forms of matter that escape our conventional understanding? These stars, in their essence, are a reminder that the universe is much stranger and more complex than we can imagine. Matter is not just what we can touch or see, but also what resides in the depths of space where the rules of physics may be completely different. The relationship between quark stars and dark matter is another fascinating aspect. Could these stars be part of the puzzle that helps us understand the matter that makes up most of the universe but that we cannot see? In this cosmic game, each discovery brings us a little closer to unveiling the secrets that the universe holds. It is a mystery that invites curiosity and drives us to keep seeking answers. As we delve into the philosophical and existential implications of quark stars, a profound reflection arises. If these stars exist, what does that mean for our view of the universe? The possibility that there may be forms of life in other corners of the cosmos under conditions we can barely conceive leads us to question our solitude in the vast universe. Are we really alone, or are there other entities observing quark stars from their own perspective? The quest for knowledge does not end here. Every answer we obtain generates new questions. What other surprises does the universe hold for us? Quark stars are just a part of a cosmic tapestry that is constantly evolving. Science is a journey, not a destination, and each discovery invites us to embark on new adventures. If we consider the role of quark stars in the formation of chemical elements, we realize that their existence could be fundamental to the creation of the matter that makes up our own bodies. Are we made of the same stars that shine in the night sky? This connection reminds us that we are part of a cosmic cycle where each star, each explosion, and each gravitational collapse is intertwined in a cosmic dance. Human curiosity has led us to develop technologies that allow us to observe the universe in ways our ancestors could never have imagined. Current and future missions to detect and study quark stars are a testament to our determination to understand the unknown. Every telescope launched into space is a testament to our insatiable thirst for knowledge. The myths and realities surrounding quark stars teach us the importance of discerning between science and fiction. In a world where information abounds, distinguishing truth can be a challenge. Quark stars are a perfect example of how science can surpass popular beliefs and open our minds to new possibilities. Reflecting on the future of research in this field, it is evident that we are only at the beginning of a path full of promises. Astrophysics is a constantly expanding field, and quark stars could offer valuable clues about the nature of the universe. The exploration of these phenomena leads us to a future where the boundaries of knowledge are constantly being pushed. The influence of quark stars on cosmology is a topic that deserves attention. By better understanding their nature, we may be able to unravel the mysteries of the origin of the universe. What role do they play in cosmic history? The answers to these questions could change our perception of reality. In conclusion, the study of quark stars is not just an academic exercise. It also invites us to reflect on our existence. It reminds us that, although we are a small part of a vast universe, our questions and investigations can have a significant impact. Quark stars in their cosmic silence speak to us of the grandeur of the universe and the eternal quest for knowledge that defines humanity. So, as we look up at the night sky and observe the stars, let us remember that each one of them, even the strangest like quark stars, has a story to tell. Each twinkle in the darkness is a reminder that we are connected to a cosmos full of wonders. Let us never stop exploring, questioning, and above all, marveling at the immensity of the unknown. The journey has only just begun.